In this video, we want to learn how we can write the terms of a recursive sequence. If you don't know what is a recursive sequence is a sequence that we can find the value of the terms in terms of the previous terms. So we don't have a specific rule to use that rule to simply find the value of each term. To find the value of, for example, fifth or sixth term, you need to know the value of the previous terms, and then you can find the value of that term in terms of the previous terms. The first example here is this. A1 is given 1, so we know that the value of the first term of this sequence is 1. But we don't know what is the value of A2, A3, and so on. But we have this relation. AN plus 1 is 3AN. Let me explain to you what is the meaning of this relation. Based on this relation, we know that the value of each term is equal to 3 times the value of the preceding term, 3 times the term before that term. For example, if you want to know the value of this term, simply multiply the value of the term before that 3 times the term before that. 3 times this term would give you the next term. If you multiply this term by 3, you can get the next term, and so on. Attention. Here we have n plus 1, but here is n. So this is the term after this term. Because when we have n, after n we have n plus 1. After n plus 1 we have n plus 2. Before n we have n minus 1. So when we say an plus 1, it means that the value of the term that is here is 3 times the term before that. Let's use this rule to find the value of the other terms. So A2, based on this relation, the value of the second term is 3 times A1. How I got this relation? If you plug in, please attention, if you plug in 1 for n in this relation, then you have A2, because 1, you plug in 1 for n. 1 plus 1 would give you 2. A2 is 3 times an, but n is 1, 3 times A1. So we plug in 1 in this relation, and we get this A2 is 3 times A1. But what is A1? A1 is 1. So 3 times 1, which is 3. Now, we say A3 is 3 times A2. The value of each term is 3 times the previous term. What is A2? From here, now we know that A2 is 3. So 3 times 3 is 9. Probably you can guess that what is the value of the next terms. A4 is 3 times A3. So 3 times 9 is 27. And finally, the fifth term is 3A4, and because A4 is 27, so the value of A5, the fifth term, is 81. Look at the next example. The first term is 12, and an plus 1 is an. Again, the value of term that we are looking for is equal to the value of the previous term divided by n. Let us start. A2, again, why we write A2? Because already we know A1. So A2 is equal to A1 over, let me write this in more detail so you understand everything fully. We plug in 1 in this relation here. When we plug in 1 for n, then we have A2 equals A1 over 1. We substitute value of 1 for every single n that you have in this relation. But we know that the value of A1, the first term, is 12. So A2 would be 12 divided by 1, which of course is 12. Now we plug in 2 in that relation. Then we have A3 is equal to A2 over 2. 12 divided by 2 is 6. We plug in 3 for n. Then A4, the fourth term, is A3 over 3. But A3 is 6. Look at the previous term. 6 divided by 3 is 2. Plug in 3 for n. Then we plug in 4 in the given relation, and we get A5 is equal to A4 over 4. A4 over 4, because A4 is 2, so 2 divided by 4 is 1/2. Attention, we are asked to write the first 5 terms. So far, we have the first term, second term, third term, fourth term, and fifth term. So this is enough for this question. Maybe when you look at here, you think that you have to find the next term, but attention. Here we had the first term, and we are asked to write the first 5 terms. So up to A5 is enough. If you want, you can find the next term, but it's not necessary. Here A1 is 1, the first term is 1, and an plus 1 is given an over 1 plus an. So we plug in 1 for n, and then we have A2 equals A1 over 1 plus A1. Because A1 is 1, so 1 over 1 plus 1 is 1/2. We plug in 2. Then A3 is A2 over 1 plus A2. It's 1/2 over 1 plus 1/2. This plus 1/2. 1 plus 1/2 is 3 over 2. And if you simplify this, this is 1/3. We plug in 3. Then A4 is A3 over 1 plus A3. But A3, the third term, is 1/3. So 1/3 over 1 plus 1/3. 1/3. 1 plus 1/3, if the common denominator is 3 over 3 plus 1 over 3, 4 over 3. If you simplify this, if you divide 1/3 by 4 over 3, let me show you how you can do this division. 1/3 over 4/3 is basically 1/3 times 3 over 4. 3 by 3 cancels, it's 1 over 4. But the easier way to do this is to know that when you divide a fraction by a fraction, when you divide this fraction by this fraction, if the denominators are the same, cancel them. 1 is in the numerator, 4 is in the denominator, so the answer is 1 over 4. Basically, it's not really necessary to divide them. Simply simplify denominator by denominator, numerator by numerator, and get the answer, 1 over 4. We plug in 4. The fifth term is 1 over, the fifth term is A4 over 1 plus A4. Its value would be 1 over 4 over 1 plus 1 over 4. Maybe you can guess what is the answer. 1 plus 1 over 4 is 5 over 4. If you look at the pattern, 1/2, 1/3, 1/4. So the answer of this should be 1/5. Now look at this example. This is a very famous example. Probably you have seen this before. This is Fibonacci sequence, which is very famous, and you can find many interesting things about this by Googling. The first term of this sequence is 1. The second term is 1. And we have a recurrence relation. Attention, the difference between this question and the previous question that we have done so far is that the value of this term is equal to sum of preceding 2 terms, sum of the 2 terms before that. So if you want to find the value of any term, you have to find the value, you have to find the sum of the 2 terms before that. Add these two to each other, and you can get the value of the next term. This is the meaning of this relation. Let us start. we start by plugging 1 in the given relation. But when we plug in 1, we get A2, because 1 plus 1 would give you A2. But already we have A2. So we start with 2. We suppose n to be 2. Then we get A3 is equal to A2 plus A1. A1 is 1, A2 is 1, so 1 plus 1 is 2. So this third term of the Fibonacci sequence is 2. We plug in 3, we get A4 is equal to A3 plus A2. The third term is 2. Look at here, the third term is 2. The second term is 1. Add these two to each other, the answer is 3. The fourth term is A4 and it's A. When we plug in 4, we get A5 is A4 plus A3. 3 plus 2 is 5. So the terms of a Fibonacci sequence are 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. You don't need really to focus on this relation. Simply, the value of each term is the sum of the two terms before that. The value of each term is the sum of the two terms before that. This is maybe the most famous sequence in mathematics. Look at this example. The first term is 2. The second term is -1. And we have this relation. an plus 2 is equal to an plus 1 over an. We plug in as usual 1 for n to see what happens. Then we get A3. We plug in 1 here. 1 plus 2 is 3. So A3 is equal to A2 over A1. A2 is -1. A1 is 2. So the value is -1/2. We plug in 2. Then we get A4 equals A3 over A2. A3 is -1/2. A2 is -1, so it equals 1/2. We plug in 3. A5 is A4 over A3. A4 is 1/2. A3 is -1/2. It equals -1. And you can find the other terms if you want. I hope by watching this video you have learned how to write the terms of a recursive sequence. If you like this video, please subscribe in my channel